Regarding the model I/O module, the core element of any language model application is the model itself. LangChain gives you the building block to interface with any language model, and it does this through prompts, chat models, LLMs, and outputs. With prompts, you can templatize and dynamically select as well as manage model inputs. With chat models, models that are backed by a language model but take a list of chat messages as input and return a chat message. By chat models, we mean models that are backed by a language model that take a list of chat messages as input and return a chat message. By LLMs, we mean models that take a text string as input and return a text string. With output parsers, we can extract information from model outputs. It's important to know the distinction between LLMs and chat models. LLMs and chat models are subtly but importantly different. LLMs in LangChain refer to pure text completion model. The APIs they wrap take a string prompt as input and output a string completion. OpenAI's GPT-3 is implemented as an LLM. Chat models are often backed by LLM, but tuned specifically for having conversation. And crucially, their provider APIs use a different interface than pure text completion model. Instead of a single string, they take a list of chat messages as input. Usually these messages are labeled with the speaker, usually one of a system, AI, and human options, and they return an AI chat message as output. GPT-4 and Anthropic's Claude 2 are both implemented as chat models. Regarding the retrieval module, many LLM applications require user-specific data that is not part of the model's trainings. The primary way of accomplishing this is through retrieval augmented generation, also known as RAG or RIG. In this process, external data is retrieved and then passed to the LLM when doing the generation step. LangChain provides all the building blocks for RAG application from simple to complex. This section of the documentation covers everything related to the retrieval step. For example, the fetching of the data. Although this sounds simple, it can be subtly complex. This encompasses several key modules: the document loaders, the document transformers, the embeddings, the vector stores, and the retriever. Document loaders load documents from many different sources. LangChain provides over 100 different document loaders, as well as integrations with other major providers in the space, like Airbyte and Unstructured. LangChain provides integrations to load all types of documents, like HTML, PDF, or code, from all types of locations, such as private S3 bucket and public website. Then we have the document transformer. A key part of retrieval is fetching only the relevant parts of documents. This involves several transformation steps to prepare the document for retrieval. One of the primary ones here is splitting or chunking a large document into smaller chunks. LangChain provides several transformation algorithms for doing this, as well as logic optimized for specific documents such as code or markdown. Then we have text embedding models. Another key part of retrieval is creating embeddings for documents. Embeddings capture the semantic meaning of the text, allowing you to quickly and efficiently find other pieces of a text that are similar. LangChain provides integrations with over 25 different embedding providers and methods, from open source to proprietary APIs, allowing you to choose the one best suited for your needs. LangChain provides a standard interface, allowing you to easily switch between models. Then we have vector store. With the rise of embeddings, there has emerged a need for databases to support efficient storage and searching of these embeddings. LangChain provides integrations with over 50 different vector stores, from open source local ones to cloud-hosted proprietary, allowing you to choose the one best suited for your needs. LangChain exposes a standard interface, allowing you to easily swap between these vector stores. Finally, we have the retrieval aspect, which is covered in LangChain by Retriever. Once the data is in the database, you still need to retrieve it. LangChain supports many different retrieval algorithms, and this is one of the places where it adds the most value. LangChain supports basic methods that are easy to get started, namely simple semantic search. However, we also have added a collection of algorithms on top of this to increase performance. These include parent document retriever, which allows you to create multiple embeddings per parent document, allowing you to look up smaller chunks but return a larger context. A self-query retriever, since user questions often contain a reference to something that isn't just semantic but rather expresses some logic that can be best represented as a metadata filter. Self-query allows you to parse out the semantic part of a query from other metadata filters present in that. We also have the ensemble retriever, because sometimes you may want to retrieve documents from multiple different sources or using multiple different algorithms. The ensemble retriever allows you to easily do this. One last aspect regarding retrieval is indexing. The LangChain indexing API syncs your data from any source into a vector, helping you to avoid writing duplicated content, avoid recomputing embedding, all of which should save you time and money, as well as improve your vector search. If you've enjoyed this video so far, it will really help me a lot if you subscribe to my channel by clicking the subscribe button and hitting the notification bell. I know most of you are not subscribed already, so you might miss out on any future content that I'll release on this channel. Please subscribe today. Thank you. I recently created a Patreon account for the data science channel. At the moment, I create my videos in my spare time while also working a full-time job. Having a Patreon would allow me to receive donations from people like you who have enjoyed the videos that I've produced so far, and will help me improve the quality and the frequency of the videos that I post on the channel. Moreover, for each of the membership options available, I will provide some extra services for those of you who decide to support me. Essentially, you can pick between 3 tiers of membership. In the associate tier, you can provide me with the equivalent of a cup of coffee. I would provide you with all the materials and the code that I use during my videos, and with a monthly live session with myself where you can ask questions and we can discuss various topics related to data science. If you want to support me even further, you have the senior data science scientist tier, where I'll also provide you with monthly one-on-one sessions with myself, where I'm going to provide you with guidance, mentorship, and answer any questions regarding your data science journey. Finally, for those of you who are more generous, you can opt for the lead data scientist tier, where I'll be happy to provide weekly one-on-one mentorship sessions, and as a bonus, I'll produce a 1-hour-long tutorial about the data science topic of your choice once you've been a member for 12 consecutive months of the lead membership. Each higher membership will contain all the benefits of the previous membership tier. So for senior data scientists, you'll also get the benefits of an associate data scientist, and for a lead data scientist, you'll also get the benefits of an associate and senior data scientist. I would definitely recommend you to consider supporting me in this journey. One last module to cover is the agents module. The core idea of agents is to use a language model, choose a sequence of actions to take. In chain, a sequence of actions that is in code. In agent, a language model is used as a reasoning engine to determine which action to take and in which order. There are several key components here. The agent itself, which is the chain responsible for deciding what step to take next. This is powered by a language model and the prompt. The inputs to this chain are tools, script descriptions of available tools, user input, that is the high-level objective, and finally intermediate step, that is any action where tool input pairs are previously executed in order to achieve the user input. The output is the next action to take or the final response sent to the user. Agent action or agent finish. An action specifies a tool and the input to that tool. Different agents have different prompting styles for reasoning, different ways of encountering inputs, and different ways of parsing the output. Besides the agent, other important components are the tools, the toolkit, and the agent exec. Tools are functions that the agent can invoke. There are two important design considerations around giving the agent access to the right tools and describing the tools in a way that is most helpful to the agent. Without thinking through both, you won't be able to build a working agent. If you don't give the agent access to a correct set of tools, it will never be able to accomplish the objectives you give it. If you don't describe the tools well, the agent won't know how to use them properly. LangChain provides a wide set of built-in tools, but also makes it easy to define your own tools, including custom description. Regarding the toolkit concept, for many common tasks, an agent will need a set of related tools. For this, LangChain provides the concept of toolkits, groups of around 3 to 5 tools needed to accomplish specific objectives. For example, the GitHub toolkit has a tool for searching through GitHub issues, a tool for reading a file, a tool for comment. Finally, the agent executor is a runtime for an agent. This is what actually calls the agent, executes the actions, chooses, passes the actions, outputs back to the agent, and repeat. In pseudocode, it can look roughly like this. While it may seem simple, there are several complexities this runtime handles for you, including handling cases where the agent selects a non-existent tool, handling cases where the tool errors, handling cases where the agent produces output that cannot be parsed into a tool invocation, as well as logging and observability at all levels, to standard output and or to line